Hello everyone, welcome back to my channel Electrical Concepts. My name is Avigyan Roy. So in my previous video lecture I have discussed about the load curve, its importance and also about load factor. Okay, so in this video lecture we are going to look at different important terms and some factors that are related to the load curve. Okay, like we will first understand what is connected load, then maximum demand, then also the diversity factor, demand factor, load factor, all these things. So we'll see one by one. So let's start. So let's discuss some important terms related to the load curve. So first we need to understand two terms. One is connected load and one is maximum demand. So sum of the ratings of all equipments is called the connected load, and the highest demand of load obtained from the load curve is known as the maximum demand. It will be clear by this example. See, suppose a consumer has 540 watt bulbs, 300 watt fans, 1000 watt AC, one 500 watt water pump, and miscellaneous, for example 100 watt. Okay, so if you add them up, you will get a connected load of 2100 watt. You just add them. 5 multiplied with 40 is 200. Similarly 300, 1000, 500 and 100, you will get 2100 in total. So that is called your connected load. Alright, now let's understand what is your maximum demand. So maximum demand you actually get from your load curve. Okay, so although in actual scenario load curve is continuously varying, okay, but for the sake of simplicity here I have made this table where only three time intervals I am showing: 0 to T1, T1 to T2 and T2 to 24, that means 24 hours. Okay, and for the sake of simplicity I have considered that only load is varying in these three intervals. Okay, so first 0 to T1, suppose one fan and water pump, these two equipments are operating. Second, two bulbs and AC. Finally, three bulbs and two fans. So in this case, if you add them, you will get 600 watt of load. Similarly, in second case, 1080 watt of load, and finally 320 watt of load. Okay. So now as you can see, among these three time intervals, 1080 is maximum. That means your maximum demand is 1080. Okay, so now I think you got an idea of what is connected load and what is maximum demand. All right. So demand factor is nothing but the ratio of maximum demand and connected load. You have already understood what is maximum demand and what is connected load. See here. So if you consider this example, if you take these values, if you take these values, you will get this demand factor. So actually demand factor signifies the demand at the consumer side. Okay, so higher the demand factor, higher will be the demand at the consumer end. All right. So next we'll understand what is average demand. It is nothing but the average of total load occurred in a given time period. Okay. So for example, if I again refer the previous example, see, uh, I am assuming that 600 watt is consumed for 4 hours, 1080 watt is consumed for 8 hours, and 320 watt is consumed for 12 hours. So the total consumption will be 14,880 watt hour. Okay, so you will get 620 watts. So it will be your average demand. Alright, so I think you have understood, it is clear to you. Next we'll see load factor. It is, I have already explained this in my previous video lecture. Okay, so it is nothing but the ratio of average demand to the maximum demand. Okay, so again by referring the previous example, see, 620 watt by 1080 watt will give you the load factor. See here I have already determined the average demand to be 620 watt, and see here I have determined the maximum demand to be 1080 watt. So the load factor will be 620 watt by 1080 watt, that means 0.574. Higher the load factor, lesser will be the cost per unit generated. Obviously, because if your load factor is very high, that means your maximum demand will be less. Okay, so for example, your load factor is very less. What does that mean? It means your maximum demand is very high and your average demand is very less. So your average demand is much more lesser than your maximum demand. It means that your cost per unit generated will be also very high, because although your average is very less but your maximum demand is very high, so automatically your cost per unit generation will also be very high. That is why higher load factor is always preferable. All right. Next is higher load factor also reduces the cost of the plant, because higher load factor means lesser maximum demand. So your maximum demand is reduced or less, that means automatically your cost of the plant will also be reduced. Next we'll see what is diversity factor. The ratio of the sum of individual maximum demands to the maximum demand obtained from load curve is called diversity factor. Let's understand this by an example. See this table here. I have assumed three consumers. Okay, although it is just a hypothetical concept, although in actual scenario these things are completely different. There are so many consumers. Okay, in actual scenario there are so many time intervals, but here for the sake of simplicity I am assuming in such a fashion. So only there are three consumers. Okay, and these three are the time intervals. Okay, say consumer 1 has different power consumption like 0.5 kilowatt, 1 kilowatt and 0.8 kilowatt. So among these three, 1 kilowatt is the maximum individual demand for consumer 1. Similarly for consumer 2, 3 kilowatt is the individual maximum demand. Similarly for consumer 3, 5 kilowatt is the individual maximum demand. And as you can see, these three maximum demands, individual maximum demands, are not happening at the same time. Okay, it is rarely seen that all the maximum individual maximum demands are happening at the same time. In real case, this individual maximum demands happen at different times. Okay, and see here total means your data of the load curve. So in load curve, obviously for 0 to 4 hours the load curve will show the summation of these three values, that means 6.5 kilowatt. Similarly for 4 to 16 hours again load curve will show the summation of these three values, that means 5.5 kilowatt, similarly 5.8 kilowatt. So from load curve you will get 6.5 kilowatt to be your maximum demand. Okay, maximum demand obtained from the load curve. All right, now it's very simple. Sum of individual maximum demand is 9 kilowatt. All right, see here 1, 3 and 5, that means 9 kilowatt. Similarly maximum demand obtained from the load curve is 6.5 kilowatt. I have just shown. That means your diversity factor becomes 1.385. that means your diversity factor is always greater than 1. Okay, and greater diversity factor means lesser will be your cost of power generation. Why? Because greater diversity factor means your denominator is reduced now. And what is the denominator? Denominator means the maximum demand obtained from the load curve. That means your load curve is showing a reduced maximum demand. That means if your maximum demand is reduced, automatically cost of power generation will be reduced. Okay, so I hope you have got a clear view of different terms related to the load curve. So I hope you have enjoyed this video. You have understood all the important terms and factors and their significance. Okay, so if you have understood this thing, please share with your friends, like it, comment and also subscribe to my channel.